Hi everyone, in this part 2 video about my home network, I'm going to be taking a deeper look on how things are set up. I'm going to be covering the virtualization, the networking and a firewall setup. In future videos I'm going to be setting up a new NFS data store, a new VLAN and doing some troubleshooting steps, because when things do go wrong it's nice to know a few troubleshooting steps to try and sort them out as quick as possible. Thanks for watching and please look out for my future videos. Thank you. Okay, so let's have a little bit of a deeper look into how the network's set up. This is quite an overview. It looks quite complex, but once you break it into its individual parts, it's not actually too bad to work on. So let's have a bit more of a look of how the switches are set up first. Okay, so we're having a look at the switch links now. You may wonder why I've got the firewalls in this diagram. The firewalls provide the inter-VLAN routing between my VLANs. It's also an easy way to segregate the traffic and permit only specified traffic between any VLANs. So for instance, any clients or Wi-Fi, they don't get allowed onto the server network or management networks unless I allow them, because they're on different zones on a firewall. So the switches are connected via LACP links. I also run multiple spanning tree protocol on these switches, so that prevents any switching loops between the switches. They're all the same switches, they're all HP 1920 switches, which we can have a quick look at now to just show you the basic interface of these. So let's have a look at switch 1. Sorry about the keyboard sound. I'm looking at getting a shock mount for the mic, but I've spent a lot of money so far on setting up for YouTube, so it might be another Christmas present. So yeah, this is one of the switches we have, switch 1, which is this one here. It'll be connected to switch 2 and switch 3. So you can actually see that when you go into LLDP neighbor summary. You've got the 2 uplinks to switch 2 and only 1 to switch 3 at the moment, although they are set up for LACP. To switch 3 there's only 1 cable connecting at the moment on this switch. So if we can have a look at the other switch. 164. Oops. That verify code is default, by the way. So yeah, so now we're looking at switch 2, and we can have a look at the LLDP again to show the neighbors. LLDP stands for Link Layer Discovery Protocol. It's a good way to see what your neighbors are. You can actually stop it on certain ports if you want. So for instance, if I want to go onto switch 2 and block that being seen, I can actually just disable the LLDP on there. So now if I go back to switch 1 and do a refresh, it should. Might have to refresh the whole thing. So there you go. So now you can see it only shows switch 3. So for instance, for security reasons, you could disable LLDP on any client ports and just enable them on uplink ports to other switches. Although what you can do with LLDP is actually maybe try and configure it just for your trunk ports, so that way you can see the phones and switches. So let's go back to switch. If you have a switch here and enable the port scan 23 and 24, enable. Okay, let's go back to the switch now and let's do a refresh. So there you go, they're back. So that's quite quick. The other way you can do that is go in command line. These are managed switches with console ports, so you don't have to go into Web GUI. I like these type of switches with console ports because you're not reliant on having a client PC in the same network to actually manage your switch. If you're doing any VLAN work and you manage to lock yourself out of a switch, if you're reliant on a Web GUI, it can be a little bit difficult to get back onto the switch again to sort the issue out. So with a console port and CLI, you should be able to do enough to sort the issue out. Unfortunately, with these switches, they lock the command line down a little bit unless you know the usernames and passwords. So if I go on to say switch 3 here, so switch 1, load that. Let's just save the settings keyboard. Go to session and then save that. There you go. Because that little keyboard setting adjusts how the backspace key works. So let's open that. So okay, so I'm on the basic command line now. It doesn't allow you to do much on here. You see you've only got these available commands. So if I want to go in anything further, I have to actually use the what I call a secret, or the not so secret password, username password. So yeah, you have to enter this command. Click yes, just like that, and this password, which you can't change, or I haven't found a way to change it yet. I will paste those in the comments of this video. You can find them on the internet, quite easy to find on the internet. I don't know why they developers saying, they say be careful. Yeah, okay, so we're going to be careful on CLI. It's not like a Web GUI. You can back out of any changes as long as you don't save them. You can reboot the switch and then it'll take it back to the setting. So it's handy to make sure your settings are correct and don't cause any problems before you do a save. That way, if you make any mistakes and if you haven't got a backup of config, you can actually just reboot the switch and it'll take it back to its prior state before you made those changes since your last save. So if we do the there you go, see the difference. Compare with the non-entering of that command and the password. You can only initialize and telnet and reboot, ping for instance. So, but once you enable that the command line, the deeper command line, you can go a lot more. So for instance, you can go into system now, and you can go for you can display the LLDP enable information. So if we can do it short on that, probably too much information. So there you go. That's basically showing the same what we were seeing in the actual GUI here. So you got 23 and 24 connected to switch 2, 23 and 24 connected to switch 2. You can also see the spanning tree protocol from here. So you can actually do everything in this command line as long as you enter that command and that password. You can do anything that you can in the GUI in the command line. So if you do stuff yourself up and have to go into command line to rectify, you can actually do it without actually having to default a switch to the config setting, the default settings, which some web GUI switches, the only way out sometimes is actually to set it back to its default. When you've got VLANs set up and trunking protocols and IP addresses, it can be a bit of a pain to sort out, and certainly you can sort out it quickly if you had no backup. It's always wise to have a backup anyway. So one of the other things we can do is have a look at the spanning tree protocol on here as well. So here you got the same, you got the instances that I've configured, the VLANs that I've configured on the instances, region information. It can show the lot, to be honest. So port summary, say for instance we go to port 24, you can see what can you see useful here. So yeah, so it shows you the designated bridge port. It shows you the what's the port role, so it's enabled. So this is this a root bridge for that VLAN? Instance 0, just showing instance 0, it doesn't show instance 1. So there doesn't seem to be any way to show the instance. This is all the instance 0 by the looks of it, so it's a bit limiting. You can't actually see all the information from here. You can't actually see, for instance, what is the root bridge for each instance for the GUI. You actually have to do that from the command line. So the way you can do that is you can do a display spanning tree protocol root, and I think that's it, root, there you go. So there you go. So this shows you your instance IDs and actually shows you the root bridge for those. So instance 2, the root bridge is connected to bridge aggregation 1, and that's its MAC address. And so if we go to switch 3, for instance, see what a pain in the butt this entering this special command and password is. I much prefer it if I didn't use it, to be honest, but there you go. I want to go to HP switches where you don't get that problem, like a HP 2930 I think I'm looking at, but they cost about £500–600 each, but you can do proper stacking on those switches, and it's a HP command line which I'm much more familiar with. and it's easy to script things with. So let's display the span tree root. So for some reason this isn't showing the correct information here. I'm not too sure if I've configured this one properly. So let's go to the other switch, switch 2, and that should be configured correctly. Into the credentials again. Okay, so display. Oops. So go into system first, and then display STP root. So there you go. So difference is it's switch configuration. I'm not too sure if I've set the priority right. So compare switch 1 and switch 2. The root bridge for instance 1 is on this switch, and the root bridge for instance 2 is connected on that port, which is the switch. So yeah, that's the spanning tree protocol. So these switches, they do IP version 4 routing and IP version 6 routing, but it's only a light version of routing. It's not very good on the IP version 6 routing. I've not really tried it on the version 4 routing because I use the firewall for version 4 and for version 6. The firewall handles the IP version 6 a lot better than these switches do. There's various troubleshooting things you can do on here. If you want to, you can ping, you can trace route directly from switch. You can show the MAC addresses. The other quite good thing about these switches are the voice VLAN. What you can do there, you can actually get it to auto set the ports. So you designate what ports are set to auto, and you can then literally set it up correct. So for instance, I have, what switch is this? This is switch 3, isn't it? So summary. So the voice lane ID is 240 and the mode is auto, and that's on Gigabit Ethernet 1. So for instance, if I had a Cisco phone that could read LLDP MED, it could actually pick its voice VLAN ID up from this actual port on the switch, rather than having to actually configure it manually on the actual phone itself, which I think I'll demo in another video, how that's quite easy to set up. You simply add your first 6 characters of your MAC address and tell it it's a Cisco phone or whatever, as long as you add your OUI, or unless it's already in here, the switch will recognize it as a phone and then assign it to the VLAN, as long as you've got the port configured for the voice auto mode, you can do that. So I wonder if I can show anything else on voice. Display voice. Is it display voice? There you go. Display voice. Okay. Display voice. State. So yeah, that's just basically reiterating what we've got here. So let's show. It could be I've only got one. I should have two phones plugged in here. There's a possibility I've only got one showing up because the other one's unplugged. So the way you can do that is you can do a display LLDP neighbor list, and there you go. So Gigabit Ethernet 1 is actually showing it's connected on the actual port ID. Shows you the model, the system name, which you probably can configure to what you want. Shows you the MAC address. So we'll go through that in another video, I think. So that's more or less the switches. Let's say they're all the same. They're all the same model. None of them have got PoE because I've only got 3 phones and 1 access point. I'm not bothered with the PoE, to be honest. So that's it on the switch side. Let's look at the ESXi side next. Okay, so here we're looking at a diagram of the ESXi hosts. See, I have the 4 ESXi hosts here altogether. ESX1 is a little NUC, new unit of computing. It's got 32 gig of RAM and it's got a flash drive. I think it's M.2 based flash drive. The ESX3 is a lab server, only really gets used for doing MDT deployments and testing, and also some backup testing as well. The ESX2 and the ESX4, both these servers run the firewall that you saw in the previous this diagram here. They're both connected to the firewall. There's 2 links from each host back to the switches, to each switch. So therefore you've got a lot of resilience. Apart from lab, the ESX3 here, which is lab, that's only connected to 1 switch. It's pretty pointless connecting it to the other ones because it's not really needed for anything really urgent, so, or anything production related, or anything that you need on 24/7. The 3 ESX hosts here, ESX2, 1 and 4, those hold my main VMs, firewalls, LDAP servers, mailbox servers, management servers, VMware servers, PBX servers, ETM. I've got quite a few servers running in all. So yeah, these both these are Fujitsu servers. Both got 32 gig of RAM. Both got flash drives. We could take a quick look at the VMware setup. So let's have a quick look. Is that one there? Good, we've got access to this now. Let's just log in. So we're just logging into the vSphere web-based client now. This is version 6, so you can no longer use the vSphere client that you used to use up to version 6. This is version 6.5, sorry. So you can no longer use the vSphere client to connect directly to either the vCenter or the clients themselves. Here I've got the 2 clusters that I've set up. I've got a lab cluster which only holds for 1 server, and then production which holds all the rest of them, all the rest of the production servers. Now if you're interested, but belonging to the VMware user group, you get a lot more scope for the evaluation, and you get access to a lot of the technologies like the virtual SAN and stuff, and the other VMware tools you can use, like the orchestrator. You can get access to that as well if you're a member of the VMware user group. So that being said, let's have a little bit of a further look here. So we have all my VMs here. I've set up DNS for the hosts. It's good practice because some SANs, they rely on being able to resolve the VMware host via its DNS name, not its IP address. It also makes it easy if you've got a lot of these to use the name rather than the IP address. We're humans after all. We can relate to a name a lot easier than a 4-octet IP address. So we have the 3 hosts in production, 1 host in lab. I have got NFS working on here, so we've got a few NFS data stores, or only 2. This is quite handy for HA and vMotion. Just means you haven't got to move the VMDK files across servers. I've only got 1 gig connections on my network. I've not gone to 10 gig yet. So if you're moving large VMDK files around, it can take a lot longer to do that with a 1 gig connection compared to a 10 gig connection. So yeah, that's the data stores. Also handy if you rename your data stores, because by default when you add a data store, it'll add it as data store 1. So on here you'll see loads of data store 1s, 2s, 3s, etc., but you won't necessarily know which host they're actually on. So it's a good idea, I think, to name the host, add the host name in there to the data store. So it's a simple matter of renaming. You can name these to whatever you want, to be honest. You know, it's quite simple. You can simply rename it here. It doesn't cause any problems. On the networking side, I've just started to use virtual distributed switches rather than virtual standard switches. If you've got multiple hosts, the virtual distributed switch, it's a lot easier to put that out to different hosts. You don't have to configure the VLAN on every individual host. As long as you've got the virtual distributed switch on that host, adding a VLAN, you only have to do it once. You only have to do it here. The 2 different virtual distributed switches I've got, the RO, that's the routing distributed switch, and the VM is the VM distributed switch. I don't really need this one anymore. It goes back to when I had firewalls that weren't in a HA setup, so I used to have to disconnect the cable when I swapped over or when there was a failover, but since I run HA now on a firewall, I don't really need this distributed switch, to be honest, or the uplinks. So these only these two hosts, ESX2 and ESX4, where the firewalls are, have got the uplinks for that distributed switch. Whereas if you have a look on the VM, that's all the hosts have got this. So ESX3 has only got one uplink, doesn't really need two, but ESX1, 2 and 4 have got two uplinks which connect to the two different switches. Completely resilient. In actual fact, I've got another diagram here of the switches. So this shows you a little bit more breakdown of the actual switches and what they're actually connected to. So the management and NFS, it's only on a virtual standard switch. That's only active passive because the NFS version I use is only version 3 and it doesn't support multipathing, so I've simply got active passive. It still uses a 1 gig connection, so you know it works okay for the amount of VMs I've got on the NFS storage. They're not database VMs on those storage, on that NFS storage, so the 1 gig should be fine for the amount of VMs I've got on there. For virtual machines, yep, got one uplink to each switch. The switches are got different ports connected because switch 2 is the top switch in the rack, and I've got a patch panel directly above, so the cables go directly into there in small little 1U cables, and then from the back of the patch panel they go into each host, which I can show you quickly now from a previous video. So you can see the two ports, Ethernet onboard ports, which connect to the NFS and the management. So the WAN is another virtual standard switch. That's only got one uplink. That connects directly into the router I have. The router gives the public IP address directly to the firewall running on the actual hypervisor host. So because the firewall's in a HA, the port becomes active on the firewall when the actual firewall's active, because they're set up in active passive. Anyway, I'll show you a bit more about the firewalls then later on in this video. So yeah, that's the networking side. I think I'll show in future videos how to set up new VLANs, and hopefully by that time I'd have got rid of this one as well, and we can use the ports for something else. So yeah, that's about my VMware. So I do run them in HA, which did give me a bit problem earlier today. It's showing us down here again, and this is the one that's running on the Nuke, which I'm having a little bit of problem with. So I'm not quite sure. Not quite sure why it's not happy. I might actually move it over so this is on the other 2 or 4, and then have a witness on the ESX1. It might be a little bit happier that way. So that the witness is hardware. So it shows it's got 2 network adapters, but probably only really needs 1, to be honest. I wonder what happens if I actually disconnect the this one, because that's the one it uses for the actual HA network. So let's disconnect the other one. Let's disconnect that. There you go, and let's see what's happened. So let's refresh. It's still showing up. So the witness only really needs the HA IP address. See VMNIC here, that's the HA adapter, whereas the management NIC is the one you actually access the vCenter via. The witness only has 1 VMNIC, so I've got backup running at the moment. So that's about it on the virtualization side. If you've got any more questions, I'll try and help out. I'm not an expert on ESX. I've used it for quite a few years, since version 4.1. So I've been using it a few years. But if you've got any questions or you want to see anything specific on my environment, then please let me know in the comments. Thank you. So here we're looking at the firewall. As I mentioned, these 2 firewalls are virtual, and they're actually running on the 2 ESXi hosts, ESX2 and ESX4. They run in a active passive HA configuration, so they share IP addresses between both firewalls, and when the firewall becomes active, it switches on enables the ports, the interfaces. So we can have a quick look at that in a moment. The Draytic VDSL modem provides the public IP address directly to the firewall, so I only have one source of net issues. So let's just log in. Again, it's tied in with my LDAP, so I don't have to remember multiple passwords and usernames. Here you can see in more detail that this firewall is the active firewall, local active, whereas a peer is passive and a running config is synchronized. I've got a few mismatch here. There's nothing too much to be worried about. The PAN-OS version is obviously quite important, because if that's different, then you won't be able to get HA. And the HA and HA1 backup, those are the 2 different links that go between each firewall, just so they know which one's up between them. These are actually configured on different VMware network adapters, so they actually use different physical network interfaces. So if one happens to go down, you've still got the other one, so it will know that which firewall is up, so it can decide between both of them. which one's up and know which one's up. So yeah, say this one's active. So we can actually have a look at the passive one. Open up a new one. So this is the passive firewall we're just about to log into. And you'll be presented straight away with the dashboard, and that shows that this local device is passive and the peer is active. So on the interface side, the only interface which is active is actually the HA. All the other ones are down, administratively down, because if this isn't the active firewall. You can do these firewalls in a active, but I'm not even sure if that's supported if they're VMs. So active passive is more than enough for my needs, to be honest. It provides the resiliency for my inter-VLAN routing, the routing between VLANs, and the enables me to access the servers on different VLANs as long as one of these firewalls is up. So we can have a look at the actual interfaces. You actually see that the interface 1.2 here, 1/2, is configured as a HA, and that is it doesn't need an IP address for that. The IP address is actually configured in a separate place. The other HA link uses the actual management. So say the control link HA1 uses the management port, and HA1 backup uses Ethernet 1.2. So here's where you configure the actual IP address. You don't configure any interface, any network page of the interfaces. You only configure it here. HA2 isn't supported in the actual virtual version of the firewalls, so that's why they haven't been configured. So you can set up your device priority. This device priority is 200, so that means that this has got a less of a priority, whereas the other firewall here, you can actually see is set up with device priority 100, which the lower device priority gives it a higher preference to be in the active firewall. So if you've got an instance where you want a specific firewall to be the active firewall, you literally just give it a lower priority. These firewalls are very, very good. They're very, very powerful. So if you want to know more about what I've shown you in this video for switches, the ESXi or the firewall, please let me know in the comments and I'll try and help out where I can. Thank you very much.